We're on the final lesson of Chapter 9, Systems of Linear and Quadratic Expressions. So remember, a system of equations means that there are more than one equation, and we have to try to find where they intersect, or where these equations have the same exact solution. So since we're looking at linear and quadratic systems, that means that we will have one quadratic system, or one quadratic equation, which will be graphed as a parabola, and one linear equation, which is graphed as a graph. So if it says to solve by graphing, you'll graph each of them individually and find where they connect. Here, these illustrations show two solutions. The graph crosses twice. One solution, it crosses only at one point, and no solutions where they will never intersect. The first graph has solutions at -1, -2, that's this point here, and 2, 0, that's this point here. To the right, our solution is 0, 3, right there. Our solutions will always be written as ordered pairs, your x, y. Solving by elimination. The goal of elimination is to cancel out one of the variables. So here you can see we have y equals -x squared plus 39x plus 64, and y equals 28x plus 4. So if our goal is to get maybe our y's to cancel out, I'm going to subtract my y equals 28x plus 4 from that. Now, notice how I put parentheses around the equation and I lined it up. The parentheses remind me that I need to distribute that negative throughout. So I'm going to have a -y, a -28, and a -4. I'll go ahead and add those straight down. When I add those straight down, I get 0 equals -x squared plus 11x plus 60. Now, I'm no good at factoring when I have a negative out in front, so I'm going to divide my entire equation by a -1 to get rid of the negative in front of my x squared. When I do that, 0 divided by -1 is 0. -x squared divided by -1 is just positive x squared. 11 divided by -1 is -11x. And 60 divided by -1 is -60. So this looks like something that I'll be easily able to factor in order to solve. And I am going to look for two numbers that multiply to be -60 and add to be -11. So I know my multiples of 60 are 1 and 60. That wouldn't work. I know this last term here is negative, so one of these will have to be negative and one of them will have to be positive. Since I want them to add together to be a negative, my larger one will be negative. 1 and -60 don't add to be 11. 2 and -30, but those don't add to be -11. 3 and -20, but those don't add together to be -11. 4 and -15, there we go, we found our factors. So 0 equals, I'm taking this up here, 0 equals x plus 4, x minus 15. So to solve them out, we set both of those equations equal to 0. X plus 4 equals 0, or x minus 15 equals 0. And then we solve it out. -4 minus 4, x equals -4, or plus 15 plus 15, x equals 15. So our solution is x equals -4 or 15. So in the last slide, this is where we ended, x equals -4 or 15. But remember, I said these solutions will always be in a coordinate pair. So now we need to go ahead and solve for what y would be. So we're going to plug it in. I'll pick one of the equations, maybe the first one. Y equals 28 times -4 plus 4. 28 times 4. 8 times 4 is 32. 4 times 2 is 8, plus 3 is 11. So we have y equals negative 112 I had to process what I was doing, negative 112 plus 4. So y equals negative 108. Then I can go ahead and plug in for 15. Y equals 28 times 15 plus 4. So let's work that out. 28 times 15. 8 times 5 is 40. 5 times 2 is 10 plus 4 is 14. Our placeholder, 1 times 8 is 8. 1 times 2 is 2. And so we get 0, 12, 420. Y equals 420 plus 4. So y equals 424. So when we write our solutions, again, there is ordered pairs. So our first solution is negative 4 times negative 108. And our second solution is 15, 424. And that is our solution set. Now the final method is substitution. Remember, there's always these three methods for solving systems. There is graphing, there's also the table method, but that can be very hard, just going through and plugging numbers and plugging numbers and plugging numbers, and that's kind of like guess and check. There's elimination, and then there's substitution. Substitution is where you replace one of the variables with the other one. So both of them, we have them solved for y. We know y equals x squared plus or minus 6x plus 10, but we know that y also equals 4 minus x. So if they both equal y, they both equal each other. Which property is that? Transitive property. So x squared minus 6x plus 10 equals 4 minus x. Then we can go ahead and solve them. I'm going to add x to both sides of my equation. Negative 6x plus x will get me a negative 5x plus 10 equals 4. I want to go ahead and try to solve this. So I will subtract 4 from both sides, subtract 4, and we get x squared minus 5x plus 6 equals 0. So we look at this and say, is this factorable? Can I come up with two numbers that when multiplied together equal positive 6 and when added together equals negative 5? Well, of course. We have x minus 2 and x minus 3. Looking at that, we can see that our solutions will be x minus 2 equals 0 or x minus 3 equals 0. Solving it out, we have x equals 2 or x equals 3. So we have our x values, but now we need to go ahead and find our y values. So I'm going to take this for the second equation, y equals 4 minus x. That seems to be the easiest one, and plug in what my x values are. Y equals 4 minus 2. So that means y equals 2. Or y equals 4 minus 3. So that would be y equals 1. Our solutions need to be written as ordered pairs. So the first ordered pair would be 2, 2. Second order pair would be 3, 1. And that is our solution set. I hope this video was helpful for solving systems of quadratic and linear equations. Our joke of the day: what do you call a mound of cats? A meowton. Oh man, you've got to be kidding me right now.